Jai Hind. In today's lecture, we are going to cover doubly linked list. In doubly linked list, mainly we will take the operations starting with the introduction. So after covering introduction, we'll talk about the operations on doubly linked list in specific display, insertion and deletion. So let us start with what is doubly linked list. In doubly linked list, we have two-way pointers. Two-way pointers means we will have a collection. What is a linked list? A linked list is a way to store data in nodes through links, and how these links are used. When we will be storing one data, it will contain the address of the next node where next data is stored, and that will have the address of next node and so on. For example, if I talk about this, my address of my linked list first node is stored in head. So here information is A, it is having pointer to next node, which one is having pointer to next node and so on. So all the nodes are linked to each other, linked to one and then to next, then to next. In specific, when we have to traverse the list, what we do, we start from head, then we take its next pointer to go to next node, then next pointer of that second node to go to next node and so on. So the data is stored in terms of nodes, and first node contains the address of second one contains the address of third one and so on. So now let us talk about doubly linked list, which is our topic today. In doubly linked list, what we will have the data, we will be going to store the data in terms of nodes only. And what is our structure of the node? The node we will be taking as containing the data, that is the information which is to be stored, plus a pointer to previous node, that is struct nodes are previous, and a pointer to the next node, that is struct node star next. So how it is different from a singly linked list? In singly linked list, we have the data field and the next pointer. The next pointer contains the address of next node. Now what it will contain? How doubly linked list is different? In head, we will have the address of first node. In this first node, we will have the data that we need to store. And after that, what else is there? It will contain the next pointer, which will contain the address of next node. In addition to this, which is stored in singly linked list, what we have? An address to previous node also. So we are having two parts here, two pointers here, that is struct node previous and struct node star. So if I draw a singly linked list, I will have this information. Let me say the data is same, A, then pointer to next node. It is our next node. Then we will have pointer to next node. What we are having here and so on. What we are having here, the first node will be stored somewhere. Let me call that head or start or whatever name we prefer to take. But in doubly linked list, what we are having a pointer which is pointing to previous node also, which is pointing to previous. So in a node, we are storing the data of the next node as well as the previous node. So if I take example of this particular node, let me take this node is some temporary considerable node. So I am considering it as temp. If I see this in temp, I have stored data B. So what is my data here? B. What else I have? I have one pointer previous, PREV. So this is my previous pointer. What it is containing? It is containing the address of previous node. This is my previous node, that is the node before this in the given linked list. We all should remember that the linked list have the sequential access. Sequentially, we have to go from one node to another node. So what I said here, it will have the previous pointer which will contain address of the previous node, the last node. And I will have another pointer which is my next pointer. What the next pointer will contain? The next pointer will have the address of next node. Previous pointer is having the previous pointer is containing the address of predecessor node, preceding node, and next is containing succeeding node, next node, following node. Okay, so this is the doubly linked list structure. So what we are having here, we are having struct node, the node type which we are creating with 2 pointers. So this is our doubly linked list. Here we are having few points that we will talk after doing the insertion operation. So now let us write the code for doing the insertion in doubly linked list. So what point I have taken here, I am having this linked list which is doubly, so it is having previous pointer as well as next pointer. So what I have taken here, we will add a node at the front. Front means here. This is my starting. Here I will add a node. So what is the way to do? So whenever we add something to a linked list, it means we have to create a node. So when I am saying that we have to create a node, it means we have to allocate memory first, and then we have to set the parameter such that it becomes one node of the given linked list. The links have to be set up in that manner. So now when I am saying that the links have to be set up in that manner, in this specific example, we will set up the links such that it becomes the first node. So that is the most important point here, that how to set up the links, because these are the links only which will make a position in the linked list. Here our linked list is W1. Okay, so now let me take the function name as the insertion at front. So insert front I am writing. So my function will be insert front. What I have to add some data. Let me take the data A, B, C, D, all are integers. So let me take, I will add integer. Why I am taking this as integer? Because we have taken the structure like that. Int b, the date, our structure is storing int data. So I will have a value. Let me say in main function, I am having value 10, which is to be inserted. So what I will do at some position in main, I will call the insert front function. Insert front function I will call. What I will send to it, the value which is to be added at front. What else I will add? What else I will send at argument? My linked list. What is my linked list? Let me call it head. Okay. Now when I will add something to the front, okay, so head will get changed. Why will get the new value? Why? Because head is pointing to the first node, and when we will add something in the front, it means we will create that as we actually are creating the first node. So after creation of that node, head should point to that. Okay, so what I need here, that is call by reference, because that change in head should be reflected in main. So I am sending from here the address of head, because head will get changed later. So what will be my arguments? My arguments will be struct node. So what I am sending from here, head is a pointer to first node, and I am sending address of that. So what does it mean? I am sending here address of head. So I have to take here the address of head. That's why I'm taking double pointer. So let me take it as head address. And what is the other thing that has been sent? Int val. So this is my function header. I'm getting my head address, that is my, information about linked list. What is information about my linked list? The address of first node. Okay, now what we will create? We will make a change in that. What change I am going to make? I will have a node here. In that node, I have to store the value which has been sent from the main. Main was having some address allocated to head or maybe null, whatever it was. And then what I am doing, I am sending some value, that is val. Okay, so now I have to create this node and I have to put it somewhere here at start. Okay, I'm putting it at start. So what I need to do first, I have to create a node. Okay, and I have to store the value, the first step. The node should be created and it should be containing the value that is to be stored. So I'm creating a node, struct node star temp. Now what I'm doing, I'm allocating memory to this. Temp is equal to struct node star malloc size of, how much size I have to allocate? That is equal to struct node. So what happened here? At this point, I have allocated memory. How much memory? Equal to size of struct node, and I typecasted that the address return will point to struct node star. This much amount of memory has been allocated. How much amount? Equal to this. So I have been allocated this memory, which is having one previous pointer, then data, then next pointer. Okay, so node has been created. So what is the first work done? The node has been created. Now what I need to do, I need to store the data. Temp data. Temp is my new allocated memory address, and I will take the data part of the node which has been created at that address, and I will store the value here. Value has been given. Now what happened? Some value was sent there, was sent from there. So let me consider that as E value. Some int equivalent to E. So my node has been created. Now node has been created, value has been stored. Now what is our job? Our job is to make it the first node. We have to store this as the front. So what is our identification of first node? The previous pointer of first node is always null. Why? Because it is first node, so it is not having any preceding node. And head will store its address. Okay, head will store its address. And what is same way the identification of last node? In that previous node is having some, previous pointer will have some address, but next pointer will have the null address. Okay, so these are our two standard nodes in which previous and in one previous node is null and in one next node is. So we are using the, we are doing the insertion at front. So our previous node will be null. So what we will do here, temp previous will be null. Okay, so what happened here? It is null now. Now only one thing is left. What is left? That is the important point here. One thing is left. What is that left thing? next pointer is to be set. Now what will be the next node? We are having a linked list which is having the address stored in head. Now we are going to add it to a node to this. It means the existing first node will become the second node. And what will become the first node? The new allocated one. That is temp in this particular case. So what we will have? We will set the next pointer as pointing to that node which was previously first node. What is address of first node? That is head. Okay, we are having that in head address. So what we will have here? Star head address. Star I have taken because it is address of head. So we will take the contents at address of head. So what happened? We have put address here, previous as null and next as head. Head means this. Head was pointing to this. So we are having now this node placed in such a way that when it will be made head, it will point the its next pointer will point to the previous first node, so it will become second in the resulting list. Now what we have done? We have created our node, we have set all the values. Now what else is to be needed? What are more points that we have to consider? There will be 2 points. What are the 2 points? We have created node, we have set its values, but what is required? Head should point to this. What should point to this? Head. Okay, so when we will make the change in head address, so what will happen? Head will point to this, and when head will point to this, automatically it will become the first node. Okay, so first thing is what we have to do, the 2 remaining work that we have to do. First one is we have to make head point to this. Okay, so we will change the star head address. Now what is the second point? It contains the next address as the previous first node, that is this particular node. Okay, now what this node is containing, it is having some next address, but its previous address is null because it was first node initially. Now what it will point to? That is important here. Okay, now it has become second node, it must point to the first node. And what will be first node now? That is the one which is having address in head. Okay, so now we will make the 2 statements change. What are the 2? Head address will be changed, it will become temp. Okay, so what happened? Now this link has been destroyed. Okay, now head is pointing to this. Head is pointing to this. Now what else I told you? Head is pointing to first node is pointing to second node, but second node, as it is doubly linked list, should also point to first node. It means what I need to change? What is to be changed? We have to change the value of second node, previous pointer. What is the second node? Second node is temp next. So what I have done, I have taken previous of temp next. Temp is this, its next is this, its previous will be set as the new star head address. So what happened now? This null has been, this link has been destroyed, and here we are pointing now to this one, the previous one. So now we have set all the pointers and we have added the node at the front of a linked list. So this is our doubly linked list insertion. So now let us try the same thing for deletion. Same thing means we are going to delete the first node. For deletion, we are doing the same thing. So let me take it as a delete function. I am going to delete from end. So I am going to, initially I was adding at end, but now I am doing firstly the delete operation. In delete operation, what I'll do, I'll delete from front. The same things I am having, the same operations we are doing, that we will do for addition. Addition can be done at front, at end, or in between at some location or after some data. So what I'm doing, I have inserted at front, now I'm deleting from front. So when I said I'm deleting from front, what does it mean? It means I have to delete this one. Okay, so now let me take the delete front function. Delete front. As I will delete the front, it will change my head. So I need double pointer. Struct node star head pointer. Head pointer means head address. Head address. So what else we can have? We can display the data deleted here, or we can return it as the return value from the function. So if we want to display here, then we will simply take it void. If we want to return to main, we will take it as int. So that are the two possibilities that we are having here. So let me display here only, because our main aim is to learn the setup of link. So what I am having, I have been given this particular linked list. Delete function I am writing here. Okay, so what I have to delete this one. So to delete this, firstly I have to check, is it empty? Okay, if it is empty, then what is required? Nothing, just we will display the message. So if star head address, it means the address at star head is null. Null means we are not having any node. Then simply print linked list is empty. Okay, else what we have to do, if it is not null, it means we are having a node here. So what is required? We will take it in temp. We will take here, we will declare here as struct temp, struct node star temp. Why I am using temp? Because I have to take this node out from the list and then free the memory. Okay, so temp I am taking as address at head content. So head address content I have taken in temp. Now I have to delete it. It means what I need to do, I have to make head point to this. This means the next node in the linked list, the second node. Okay, so head will point to star head address. It will point to second node. What is second node? The first node address is temp. The second node address will be temp next. Temp next. Okay, so what we are having, this we have to delete, so we have taken it in temp. Before deleting this temp node, we will set up all the links so that the remaining list will be B, C, D. So what I did, the head address I changed to temp next. What is temp next? This one. This is temp next. So head will point to this. This change I have made. Okay. Now, as head is pointing to this and this is pointing next to next and so on, the linked list is okay, but only one thing is left. What is that? The first node has been deleted, will be deleted. So what B will become? This particular node will become first node. Now head is containing its address. So this will become first node. What is identification of first node? Its previous pointer will be null. Okay. So star head address previous pointer will become null. Initially what was there? It was pointing to this node. Now it has been broken and it is now null. Now see what is happening. B, C, D are three nodes. B's address is given in head. B's previous node is null. What does it mean? It means the links have been set up. What we will do now? We will display the data, that is, let me call it print. I will print temp data using whatever language command we are using. Okay, so temp data we will display and then we will free this memory which has been taken by temp. When I said free temp, it means now this memory has been freed. So what happened now? The first node has been deleted. Now head is pointing to this node. So what we have done in this particular slide, we have deleted a node from starting. First node has been deleted. Okay, now let us go through the advantages and disadvantages of doubly linked list. In singly linked list, we were able to traverse in one direction, it is in forward direction. But in doubly linked list, we can move reverse also. Why? Because we are having previous pointer also. So we can move both in forward as well as backward direction. Okay, as we are having a record of previous data also, previous node also, so delete operation is more efficient in this. We can quickly insert a new node before a given node because we are able to access in both the directions. Okay, so that is our advantages. And what about disadvantages? As we are having the two pointers used here, so naturally it will consume extra space in comparison to singly linked list. And because we are maintaining pointer to previous also, so our linking process is also somewhat lengthier in comparison to singly linked list. So in this particular lecture, we talked about what is doubly linked list. Then we talked about how to do insertion at front and deletion from front. Thank you. Jai Hind.